No, are you presenting your work? If you're not ready to present, you can present the next time. Are you ready to present? So when I call you to present, you can give me two answers. Yes, I'm ready. I can show my work, right? Or second one, oh, I'm not ready this time yet. I can do next time.
Yeah, I'll do it next time because I can't
Okay,
share
all right,
everything.
thank you. Raphael,
Yeah.
do you
want
like
me
to
to
show
explain?
39?
Yeah, sure.
Okay, you may present it.
I mean, I really don't understand how to share my work, but I could try to explain it just with words. That helps.
Okay, let's see how, right.
All right. So you want me to go?
Yeah, go ahead, try it.
All right. So we start with the derivative of cotangent x is equivalent to negative cosecant squared x, right? So we know
No, you
that
want to
cotangent.
prove that. You don't start with that. You want to prove
Yeah, I know.
derivative of cotangent x is negative cosecant square x,
You need
right?
to start with the given. That's how proofs are, no?
No, that's not given. That's ask you to prove. To
Okay,
prove the
so
left-hand side equals to the right-hand side. It's not given.
yeah, okay. So then you take the you convert cotangent to its actual form of tangent. So it's 1 over tangent x is equivalent to negative cosecant squared x. And then, right?
Yes.
And then you convert that actually to cosine x over sine x, right? So you take the derivative of each. So the numerator of cosine x has a derivative of negative sine x, and the denominator of sine x has a derivative of cosine x. And what I like to think here is just kind of crisscross.
Stop right there. Which
Yeah.
rule you are applying? Yes, each
Well,
individually derivative, you're right. But here we're not having individual functions. We have a quotient function. We have a cosine divided by sine.
yeah, no, I know.
Okay, so
I
which rule we should apply?
the quotient rule.
The quotient rule. What does the quotient rule say?
So you take the denominator g of f, multiply it by the derivative of f of x, which is the numerator, and then you would subtract that with the numerator of cosine x multiplied by the derivative of the denominator, which is g of x, which is cosine x. So you end up with negative sine squared minus cosine squared x over, and then you take that all over the square of g of x, which in this case is the denominator of sine x. So it would be sine x squared,
Good.
right? And
Yes.
then we also know that negative sine squared x minus cosine squared x is actually equivalent to negative 1. And that's using sine squared, the identity of sine squared x plus cosine squared x equals 1. And then that's all over sine x squared. And then we know that 1 over sine x is actually cosecant. And then we distribute the negative, and it's also squared. So it'll be negative cosecant squared x is equivalent to negative cosecant squared x.
Great. Okay. Yeah, this is the way you get credit. Okay, Raphael, like you get a credit. Thank you.
Okay, thank you.
All right, let's see next one. Alexandra? Alexandra?
Yes.
Okay, you're here. Do you like to show us the next one, which is 42?
42. Okay, do you want me to do A or A, B, and C?
Just do one. Just do 42A.
Okay, so 42A, we have f plus g prime of 3. Then in simpler terms, we have f prime of 3 plus g prime of 3. And since you have given values, f prime of 3 is equal to negative 6, g prime of 3 is equal to 5, and so negative 6 plus 5 is equal to negative 1. So f plus g prime of 3 is equal to negative 1.
Right, okay, so this is simple. Thank you.
Yeah.
You
Hey,
read
can I
it.
do B?
Who's this?
Ursa.
Ursa? Oh, sure. Try B. Ursa, are you there?
Yeah, I'm sorry, the mic was off. So for f of t is 4 and g of 3 is 2. So here the function you're multiplying. You could hear me?
Yeah, go ahead. Keep going.
So the derivative f of 3 is -6 and g of 3 is 5. When you multiply, you get -30.
You finished?
Yes.
Okay, you get -30?
Yes.
How do you get -30? I don't get -30. Let me see. No, that's not right answer. That's not the right answer. Try again, okay? Anybody wants to show B? Let me get someone else to show it. Alexandra, Euridia, I guess is still not here. Emily Chen, Emily.
No, I'm here.
Okay, you want to try 42B?
I was kind of confused about that. Can I do C instead?
What's the difference? Let's see. C, okay, C, okay, B is product, C is quotient. Okay, go ahead, try C.
Okay, so according to the quotient rule, it's f prime times g minus f times g prime over g squared. So f prime I got -6, g is 2, -6 times 2, which I got -12, minus -20. So -12 plus 20 is 8, and g squared is 3 squared, which I got 9. So the final answer, I got 8/9.
G squared is what?
9.
Why?
No, I'm sorry. It's 25.
G squared is 25?
Yeah, no, I'm sorry. I'm reading the question wrong. It's 4. It's 8 over
Okay, so
4.
what's your answer?
2.
I mean the answer for C. What's your
2.
result for C?
2.
2?
Yeah.
Okay, that's not right. Okay, anyone else want to show? Let me just get someone else to show it. Thank you, Emily. Jason?
Hello. Do I do B or C?
Do B, please.
B. So
Okay.
I use the product rule
Wait.
first. Yeah. So I use the product rule. So first, f of x or f of 3 is 4 times g prime of 3, which is 5. I mean, at first I use f prime of 3, which is -6, times g, which is 2, g of 3, which is 2, plus f of 3, which is 4, and then g prime of 3, which is 5. And then I simplify by doing -6 times 2, which is -12, plus 4 times 5, which is 20. So -12 plus 20 is 8.
Okay, great. You got the credit. So that's Jason. All right, next one, Angel, Denise.
Hi.
Okay, all right. You want to try C?
Yeah.
42C.
So what I used here is the quotient rule, which is f prime g minus f g prime over g squared. So it's going to be f prime of 3 times g prime and times g of 3 minus f of 3 times g prime of 3 over g of 3 squared. Then the numerator is going to be negative 6 times 2 minus 4 times 5, and the denominator is going to be 2 squared. Then simplifying, it's going to be negative 12 minus 20 over 4, which is equals to negative 32 over 4, and equals to negative 8.
Great, thank you. You got credit.
You're welcome.
All right, next one. Julie. Julie, you want to try 48?
Yeah, I can do 48. If you want, I could take a picture of it too and just try to present that.
Oh, that'd be great.
Okay.
Okay, 48 is find the equation of the tangent lines to the curve, right? So think about y as f of x. F of x equals x minus 1 divided by x plus 1. It's a rational function. So here we have to remember two things. The first thing is to apply the quotient rule to take the derivative, right? And then once we have the derivative function, we can find the derivative at any point. But then the second condition is and this tangent line is parallel to another line. So we have to use that knowledge.
I think you have to make me a presenter so I can share the content.
That's right. Let me stop sharing this. Let me make you a presenter. Yeah, you're the presenter now. You ready?
Yeah, let me just upload it right now. Okay, so can everyone see that?
Yeah.
Okay, so this is the first part of the question. I did the second part on the second page, which I'll show later. So for 48, we know that the equation is y equals x minus 1 and then x plus 1. And so we want to find the parallel line. And so of x minus 2, y equals 2, which means that the slope of that would just be 1/2. Because if you simplify the equation so that y is by itself, you would get 1/2 as a slope. And so then we have to find the slope of the tangent line, which, like the professor said, is just to use the quotient rule. And so when you use the quotient rule, you get x times x plus 1 minus x minus 1, sorry, yeah, minus x minus 1 times 1. And so you over x plus 1 squared, which in the end you'll get 2 over x plus 1 squared. And so then we have to find x such that y prime equals 1/2. And so to do that, you just make them equal to each other, and then you simplify that out. So you get 2 over x plus 1 squared equals 1/2. And if you do that, you get x plus 1 squared equals 4. And so you get x plus 1 equals plus or minus 2, and it's x equals 1 and x equals negative 3. And
Great.
I can share this. Huh?
Yeah.
All right, so
Great.
this. Oh, hello?
I said great. Keep going.
Oh, sorry. Okay, and then we have to find y values of each. So we know that the x equals 1 and negative 3. And so we plug that into the point slope form. Oh, we plug that into the equation first. So the equation is x minus 1, x plus 1. And then in the end, we get the y value of 0 and then the y value of 2. So those are the two points that are given there, and then we plug that into the point slope form. So we would get y equals x over 2 minus at half if we plug in 1, 0. And then the second equation is y equals 1/2 x plus 7 over 2 when we plug in negative 3, 2.
Right, so that means you get 2 lines.
Yeah.
All right. Okay, thank you. Perfect.
How do I
Perfect.
stop sharing? Oh, got it.
Yeah. Okay, so we have one more to go.
Did I finish the problem? Sorry.
You did.
Okay.
Beautiful work.
Thank you.
Noella, Noila.
Good morning, Professor. Could you make me the presenter so that I could share as well?
Great, I'll do it. Yeah, go ahead.
Are you able to see it?
Yeah.
Okay, so for this question, as it states, instead of finding the derivative of r of prime of r, the derivative of r at 0, we have to use f of x and g of x to simplify the question so that's easier on our end. So I just separated the numerator and denominator, found the derivatives of each, and then from there plugged in 0 for f of 0 as well as f prime of 0. And then from there I simplified r of x and set it equal to f of x over g of x. And then went further into r prime of x equals, and used the quotient rule from there. So f prime of x times g of x minus f of x times g prime of x over g of x squared. And from there I plugged in f prime of 0 times g of 0 minus f of 0 times g prime of 0 over g 0 squared. And I got a simplified solution of 1.
Okay, just one objection. Okay, right over here, r prime of 0.
This is a picture of Gottfried Leibniz. Super
Mhm.
Okay, so instead of writing this arrow, just write r prime 0.
Okay, got it.
Oh, you did it right. Okay, thank you.
Okay, thank you.
Okay, anybody has any questions?
And this right over here is Usain Bolt, Jamaican sprinter, who's continuing to do some of his best work in 2012.
Anybody has any questions? All right. Okay, let me see this. We talk about the final, right? My grading policy might change over time. So make sure you can show me you understand the material being covered. And if you do have questions, ask. But the one way is you may not pass this course by cheating. You may have someone else do your homework. You may have someone else do your exam. Because we're not in the same room, I cannot see you. But however, by presenting your work, that shows me how much you understand the material. So one thing I may change in the grading policy is to bump up the grades, the percentage for presenting your work by lowering the percentage of your grades on homework and on exams. So make sure you can show me you are understanding the material, okay? If you do not, ask. But if you try to fool me or fool yourself to pass this course, the percentage of success is very low. All right. So we have talked about, right, if you are able to catch up with the class, like some of you showed me, have done wonderful work, a wonderful presentation, that means you do understand what's going on. You know how to take derivatives. You know how to take derivatives of a single function. You know how to take derivatives of a product of functions. You know how to take a derivative of a quotient of functions, right? Because we learned the quotient rule and product rule. And today we're going to talk about chain rule. So what does chain rule do? Chain rule is saying we know how to take a derivative. Chain rule is saying how to take a derivative of a function as a composition of two functions. So this requires two things. It requires us to be able to say a function is a composition of two functions. If a function is a composition of two functions like this, and we will apply chain rule because product rule won't help us, quotient rule won't help us. So that's why we need another rule. It's called a chain rule. All right, that applies for composition of functions. It does not have to be 2 layers. It could be 3 layers, right? G of x could be, the x can be another function. So let's use this first one as example. F of x equals the square root of x squared plus 1. How are we going to see this? How do we take derivative of this? It's not a product of two functions. It's not a function. It's not a quotient of two functions. But this is a composition of two functions. How do we see that? We see that as f. We will see that as f of x equals to little f takes g as an input. We have outside layer and the inside layer. How do we see f? Little f, small f. So small f is the outside layer. What's the outside layer? It's a square root. It's a square root of x. So f just take the input of x squared plus 1. So that means I see g, I see big F as little f takes g as the input. What does f do? F square root the input. What does g do? G takes the input x, square it, then add 1 to it, right? So we see the inside layer under the square root sign, x squared plus 1, we see as another function. We see as a g function. What does g do? G takes the input, square it plus 1. What does f do? F square root the input. So now we go back to f. Now the input f is a g. Right? That means f takes x squared plus 1 as input. What does f do? F square root the input. This is the process. This is the process. All right. This is how we see a function is a composition of two functions. For big F, we see the outside layer is a square root of the input, and the inside layer is square the input plus 1. So see big F as a composition of little f and g. So with this kind of functions, composition functions, we apply chain rule. What does chain rule do? Chain rule says, okay, f can be written as f composed with g. F takes g as input. Then the derivative of big F is the outside layer derivative. Take the derivative of outside layer, f prime, but f prime takes g as input. Take the derivative of the outside layer. Do not change the inside. Keep the inside. Then multiply by the derivative of inside. Right? So f, writing big F as a composition of f and g. F prime is f, little f prime times g prime. So this is called a chain rule. All right, let's see some examples. Let's see this big F. Right? We want to take a derivative of f prime. So derivative of square root, let's use this one. Let's forget about the u and v, all right? U, forget the u part. Let's see this part. So f prime of x equals to little f prime takes g as input times g prime. So remember what's the square root? What's the derivative of 1 over what's square root of x? Remember I asked you guys to try to remember it. So the derivative is the 1 over 2 square root of x, right? So just get the, so f prime is 1 over 2 square root of the input. The input g of x is x squared plus 1. So this is the f prime. Right, f prime. Think of this u as x. F prime of u equals to half of u raised by negative half. Then when we take derivative, this is 1 over 2 square root of u. Right? So we use this form. And what is the u? U is g. U is g here, g of x. So what's g of x? That's x squared plus 1. So that's why for little f prime, we get 1 over 2 square root of x squared plus 1. So this is f prime of g. F prime of g. There was g prime. G prime is this. X squared, take a derivative of x squared plus 1. That's 2x. That's 2x. So multiply by 2x. Multiply 2, simplify with a half, becomes 1. So in the end, we'll get x divided by square root of x squared plus 1. Okay. Or if this is too much, you can think, okay, this is saying use u substitution, right? But I don't think we need this one. Just try to understand from this viewpoint. Writing a function as a composition of two functions. Then the derivative of it says a derivative of the first layer, outside layer. Why I call it outside layer? Let's see this one. This one, the outside layer is a square root. Inside layer is x squared plus 1. In this way, we know which one composed with which. Okay, let's keep practicing. Practice makes it perfect. If you want to use this notation, that's fine too. All right, d dx f of g of x, right, equals to You can think about as a d dx f composed with f takes g as input, then multiply by g prime, then multiply by d dg dx. Let's see this example. So we have here y equals to sine x squared, right? Sine x squared is inside. So let's see this one. Let's try to write this as in f of g, okay? So y equals to, let's do the first one, sine x squared. Let's try to write y equals to f of g. Then let's figure out what's f, what's g. So f is the outside layer. What does f do? F said, if you give me input, I'm going to take a sine of it. So the outside layer is a sine x. What's the inside layer? The inside layer is saying it's x squared, right? The inside layer is x squared. So g of x is saying, if you, I'm going to square the input. So give me x, I'm going to square it. So in this case, we can see y equals to f of g of x, right? That's f takes g. What's g? G is x squared as input. F takes g as input. What does f do? F takes the sine of the input, sine of x squared. So make sure you can see a function, a composition function this way. A function can be written as a composition of two functions, right? If we have f here, we have g here. Now the chain rule is saying take a derivative of f. So the derivative of y, so y prime, equals to derivative of f. What's the derivative of f? Cosine, right? But does cosine, maybe let me write one more step here. Remember, x is just a variable, right? X can represent any expression. So what's f prime of x? That's cosine x. Same thing, what's g prime of x? That's 2x, right? So I need to find out f prime of x, g prime of x. If I know f prime of x, I know f prime of g. So what's f prime of g? That's f prime takes g as input, right? What's g? G is x squared. G is x squared, right? F prime, the outside layer does not take x as input. It takes g as input. So that's f prime of x squared. Then what's f prime? F prime is cosine. The cosine x squared. Right? And that's it. We don't have to write this step. So that's y prime. That's y prime. That's a y prime, right? Okay, so this, let me put this over here. That's how we think about the composition of functions. Okay, I have a question here. Question saying, what about the derivative of g? Oh, right. That's f prime. That's not y prime. Thank you, Noella. You caught my mistake. That's f prime of g. That's f prime of g. Thank you. So now what's y prime? So y prime equals to f prime, take the g as the input, multiply g prime, right? That's a very good point. You caught my mistake. So now y prime equals to f prime of g of x times g prime of x. By chain rule, that's a chain rule part. So y prime equals to cosine x squared, right? That's f prime part. Multiply by g prime. What's g prime? G prime is 2x. Let's put 2x up front. 2x. Put 2x up front because we want the expression end with the angle. If the expression includes cosine, sine, tangent, trig functions, we want the expression ends with the angle, so we don't get confused. Because if we put the x here, later on maybe we'll get confused. So we leave the angle, the last term in the expression. So y prime in this case equal to 2x, that's g prime of x, times cosine x squared, that's f prime of g of x. Okay. Okay, great. So that's chain rule. Let's see more. So let's see B. So that's for A. Right? So this is here for A. Let's see part B. Part B is sine square x. Sine square x means sine x parentheses square. So this equals parentheses sine x squared. All right. So let's figure out this. This is different, right? So this one, what's the outside layer? So this one, outside layer is sine. Inside layer is a square. But this one, the outside layer is a square. Right, let me write it here. The outside layer is, let's use h and k. So in this case, we want to write as h k of x. So what's h? H takes the input, then square it. It's outside layer. And what's k? The inside layer. K takes the input and make a sign. Right. So the outside layer is this square term. The inside layer is taking the input and give a sign. So k of x is sine x. H of x is x squared. So if we put, so h in this case, we could see h in this case is sine square x, right? So when we take a derivative of h prime takes sine x as input. So y prime in this case equals to h prime takes a k as input, then multiply by k prime, which equals to, well, what's h prime? H prime is, well, if h of x equals x squared, h prime equals 2x, right? So get a 2x, but all x is not x, it's a sine x. So get 2 sine x. Then times the derivative of k prime, derivative of k, or derivative of sine, which is cosine. Or this is sine 2x. Right? So this is a good example to see these two functions are different. Is it sine x squared, of course, is different from sine square x, right? So the first one, the square is the inner layer function. The second one, the square is the outside layer function. So in the end, the y prime is different. One is 2x cosine x squared. You see the angle ends with x squared. The angle in the differentiation process never changed. Never changed, right? So we start with, here we started with the angle of x squared. In the derivative function, the angle is still x squared. In this case, the second one, b, the angle is x, and the angle is x in the end. It just happened, this is the formula of double angle. So we can write as sine 2x. So the angle does not get changed during differentiation process. All right, any questions? Okay, no question, we'll keep going. Okay, let's see this one. Let's figure out how do we write y in terms of composition of two functions. Right, we want to write y in terms of f of g. You see the outside layer is take the input raised by 100, right? It's raised by 100 power. Then what's the inside layer? Inside layer is qubit the input and subtract 1. We look at y as two layers of functions. The outside layer is to raise the input by 100th power. The inside layer is to take the input, put power cube, then subtract 1. Once we can do that, then we know how to take a derivative. Let's take a derivative of f prime. So what's f prime of x? It says 100 times x raised by 99, right? But f here takes g as input. F prime of g is f prime of x cubed minus 1. Or what's f prime of x cubed minus 1? F prime is 100 times the input raised by 99. So this becomes 100 times the input raised by 99. So look at this function as composition functions of f and g. And f raise the input by 100th power. So maybe I should write, so write one more step. So that's why we say y equals to f of g of x as x cubed minus 1 raised by 100th power. Okay, the outside layer is something raised by 100. The inside layer is raise the input by 3, subtract 1. If we do, once we know how to do that, how to see a function as a composition of two functions, we can take a derivative by chain rule. So by chain rule, we have, so what's g prime? G prime, let's just write one more here. So g prime of x is 3x squared. That's it, right? Because g is x cubed minus 1. Derivative of x raised by 3 is 3x squared. Derivative of negative 1 is 0. Once we have this, we can apply chain rule. So y prime equals to f prime of x cubed minus 1 times g prime of x, which equals to 100 times x raised by 3 minus 1 times g prime. G prime is 3x squared. Let's put it up front. Because 3, we do 3 times 100. That's 300. Then x squared. Right, let's write in this like this. So y prime equals f prime, takes a g as input, very important, takes the g of x as input, times g prime of x. So we multiply, then we get 300 x squared raised by x squared times x raised by 3 minus 1. I'm missing something. I'm missing raised by 99. Raised by 99. Oops. All right. Because f of g of x is 100 times x raised by 3 minus 1 raised by 99. So multiply by g prime. G prime is 3x squared. We get 300 x raised by 2 times x raised by 3 minus 1 raised by 99. So the big part of this is to be able to see a function as a composition of two functions. Then apply chain rule. All right, let's see next one. Let's keep practicing. So the next one is f of x equals 1 over cubic root of x squared plus x plus 1. Well, let's write this as a polynomial-like. So you would write f of x equals to x squared plus x plus 1 raised by negative 1/3. Right? Then we see the outside layer. The outside layer is something raised by negative 1/3. So this is outside layer. So think of, maybe we think f as k of g, k, let's see, let's write f of x as h of k of x. Let's use different letters, right? Then what does h do? H takes the input and raised by power negative 1/3. Right? What does k do? K takes the input, square it, and plus the input plus 1. So we see f like this. The outside layer is the input raised by negative 1/3. The inside layer is x squared plus x plus 1. Then we'll apply chain rule. All right, we know how to take derivative of x raised by negative 1/3. It says multiply what negative 1/3, then times x raised by negative 1/3 minus 1. Then negative 1/3 minus 1 is negative 4 over 3. But then the input is g, is k. It's x squared plus x plus 1. So the first layer, we get a negative 1/3 x squared plus x plus 1 raised by negative 4 over 3. Then by chain rule, we need derivative of k of x. What's the derivative of k of x? It's just 2x plus 1. All right. So if we want to write this right, we would write negative 2x plus 1 as a numerator divided by x squared plus x plus 1 multiplied by cubic root of x squared plus x plus 1. All right, that would be perfect way of rewriting this. Let me see if I can rewrite this. So negative 2x plus 1 as a numerator. Then denominator, this is a negative, all right, negative. Then denominator we would have, because it's a 4 over 3, so we can take out one term. So x squared plus x plus 1 times cubic root. Cubic root, let me just write a C root, okay? Cubic root of x squared plus x plus 1. So this would be perfect answer for that. Because usually when we read the expression by negative, by fraction, by negative fraction, we treat it as not simplified. So this would be a simplified version of that. So it's a negative, okay. 2x plus 1 as a numerator. The denominator is x squared plus, oh, I'm missing 3 here. So we have 1/3. So negative 2x plus 1 divided by 3 times x squared plus x plus 1 cubic root x squared plus x plus 1. Right, negative 1/3 is hiding here. Negative, because 1 times 2x plus 1 becomes 2x plus 1. 1/3, the 3 is in the denominator. All right, any questions? So, okay, train yourself to be able to see a function is a composition of 2 functions or maybe 3 functions. Let's see example 5. So example 5, g of t is equals to t minus 2 divided by 2t plus 1 raised by 9. So the outside layer is something raised by 9. Think about f of x as x raised by 9. So something raised by 9 as outside layer. Then the inside layer is this inside function. So think about this as, so g of x equals to h of k of x. What does h do? H raises the input by 9's power. So x raised by 9. What does k do? K is the inside function. K is t minus 2 divided by 2t plus 1. Okay. So the outside layer is raise the input by 9's power. The inside layer is a t minus 2. K takes, think about the x as a t, all right? T minus 2, let me just change it. So this all should be t. Okay, then we apply chain rule. So chain rule for h prime of t is just 9t raised by 8, right? Then h takes k as input. That becomes 9 times k raised by 8. Then take a derivative of k prime, derivative of k. Derivative of k, we take a quotient rule. Derivative of the top, which is just 1 multiplied by the bottom. Subtract the derivative of the bottom, which is 2 times the top. Then divided by the bottom square. We simplify, we get this. Right? So to apply chain rule is not difficult, but to see a function is a composition of 2 functions, need practice. Any questions? Okay, let's see example 6. Example 6 involves 2 things. First, we see this is a function, it's a product of 2 functions, right? We can treat this one as f, we can treat this one as g, but then each one is a composition of 2 functions, right? Let's call this part f. Let's call this part G. So y is a product of two polynomial functions, right? So let's call 2x plus 1 raised by 5 f. X as raised by 3 minus x plus 1 raised by 4 as g. But then each one we need to apply chain rule, right? Because f of x is something raised by 5 outside layer. The inside layer is 2x plus 1. Okay, let's do one by one. So first we'll apply product rule. So product rule, we take a derivative of the first one, multiply by the second one, then plus we take a derivative of the second one, multiply by the first one, right? So derivative of this, chain rule, we do 4, right? 4, move 4 up front, then subtract 1 from the 4, get a cube, we get a 4, x cubed minus x plus 1 raised by 3, then multiply by the derivative of inside. What's the derivative of inside? 3x squared minus 1. Right? 3x squared minus 1. We do the same thing for the second term. Chain rule. Right? Chain rule is saying 5, move up front, subtract 1 from 5. So get a 5, 2x plus 1 raised by 4. Then multiply derivative of inside, which is just 2. 5, 2x plus 1 raised by 4, multiply by 2, and multiply by g of x. Right? Just each one, we have to apply chain rule. So this is a combination of a product rule and chain rule. Any questions? All right, let's keep going. Let's see this one. This one we have 3 layers. Let's try to write as G. So let's try to write f of x equals to h of k of, let's say, s. J, maybe j of x. 3 layers, okay? So what's the outside layer do? The outside layer is a sine. So h of x equals sine x. What's the middle layer k do? So what does k of x do? K of x is a cosine x. So the last one, the very inner one, is the tangent x, right? You see, we have 3 layers. We have 3 layers. So the very inner one is taking the input x, put tangent in it. So we have tangent x. The middle one is put a cosine with the input. The very outside one is put a sine over the input. So if we see f as composition of h, k, j, so we see in this case. Well, then when we take a derivative, so f prime of x, f prime of x will equal to h prime. H prime takes k, j of x as input. 1, 2, 3, 1, 2, 3. Then multiply by k prime. K takes j as input. Then multiply by j prime. So 3 layers. 3 layers. Right? Okay, let's do that. So sine, very outside one, derivative is cosine. Do not change its angle. The angle of sine is cosine tangent x. Do not change inside. Right? So sine is cosine. So have this cosine. Don't change its angle. The angle stays the same. Then take a derivative of its inside. So derivative of cosine tangent. What's the derivative of cosine? Think about derivative of cosine, which is a negative sign, and do not change its angle. Cosine angle is tangent x. Do not change its angle. Just change cosine to negative sign. Right? So the cosine, derivative of cosine becomes a negative sign. Keep its angle. Then we have to take a derivative of inside tangent x. So derivative of tangent x. Derivative of tangent x is secant square. Put them all together, we get negative cosine. Look, cosine angle is cosine tangent. And the sine angle is tangent x. Okay, tangent x, angle is x. So it's very important. During differentiation, the angle does not change. Okay. Differentiation. Okay. So the angle of the trig functions. The angle of trig functions. The angle of trig functions does not change during differentiation. Okay, very important. You see the angle of sine in the beginning is cosine tangent. So in the end it's still cosine tangent. The angle of cosine here, the middle layer, the angle is tangent. So the angle is tangent, do not change. The angle of tangent is x. Its derivative stays x. So the angle don't change. Don't change the angle of the trig functions. Okay, any questions for this one? So you see composition functions can be finite and many, right? Okay, let's take a look at example 8. So differentiate y equals to square root of secant x cubed. Do we see 3 layers? We see the outside layer is a square root, the middle layer is a secant, the inner layer is a cube. Okay, let's just do that. So take a derivative of that. So we know square root of x is 1 over 2 radical x, right? So we just get a 1 over 2 radical x. But this x is a secant x cubed. So secant x cubed. Then take a derivative of a secant. Derivative of secant is a secant tangent, right? Derivative of a secant. Derivative secant is a secant tangent. Then the very inner layer, but the secant takes x cubed as angle. Angle don't change, so angle still x cubed, x cubed. Then lastly, very inner layer is x cubed. Derivative x cubed is 3x squared. So we have 3x squared here. So putting all together, we have 3x squared, secant x cubed, tangent x cubed divided by 2 square root of secant x cubed. Okay, just follow, just think, from inside out when you take a derivative. But when you try to figure out a function, the composition of two functions, you think about the very outside layer is this square root. The middle layer is a secant. The very inner layer is cube. All right. Okay, we're not going to prove the chain rule. Let's see. Okay, let's try some exercise. Let's try 2, 4, 6. All right, let's try 2, 4, 6. I'll try to finish all of them. Then I'll call people. Try 3 of them. Okay, maybe, let's see. 3 more minutes, I'll call people to show this. But, right, let's take a volunteer for this. Because it won't be fair. If I call you, you're not able to do it, then I don't give you credit for this. Okay, we'll show, okay, Amir wants to show 6. But make sure you do 2, 4 already too, all right? Malika wants to show 2. Okay, Malika, we start with you. But have you done 4 and 6 yet?
Yeah, I'm doing 4 right now, but I haven't done 6, so I'm gonna finish that.
Yeah, finish that, then show.
Okay.
Okay, 3 wants to do 4. Okay, I have 3 people already, but make sure you finish it 2, 4, 6. 3 questions, all right? Okay, just give 1 more minute, then we'll start to review these 3. Then at the same time, I'm going to assign you some questions for next class. So from A to 14. Okay, so this is for next class. So I'm going to call people to show this, okay, to show next class. So basically, we review some questions, 2 purposes. Okay, one is to review the material we have learned, and the second for me to know, how well you are done in this class. Let's see, page 120. You're right, page 120, 8, 10, 12, 14, and 22, 24, 26, 28. Yes. Yes. Okay, Amir, we start with you. 6. Let me make you a presenter.
I'm actually having trouble sharing my work, so can I just explain how I did it verbally?
Yes, go ahead.
All right. So so here we're given sine times the square root of x,
That's
and
not
what I
times.
did.
Hold on. That's not times. That's sine
Oh, I
of.
mean sine of square root of x. Sorry.
Yes, that's the
So we're
angle.
given sine square root of x, and what I did here is first I found the compositions of the regular functions. So f of x, that would evaluate to sine of x, and g of x, that would evaluate to x to the half power. Then using the chain rule, f prime times g of x, and then g prime of x, you would know that f prime is equal to the derivative of sine, which is cosine, and then g of x we know is x to the half power, so cosine of x to the half power times g prime of x, and the derivative of x to the half power is half x to the negative half. So from there we could simplify to get a final answer of cosine of x to the half power times x to the negative half power over 2.
Right, but let's not use half as the result. You know, if we see something raised by half, raised by a fraction, that's considered as not simplified. Let's go back to square root of x. So what's your final answer?
Well, my final answer was cosine of x to the half power times x to the negative half power over 2.
Try not to use a half power. Use square root of x.
Okay, so cosine of square root of x times, let me see. We would have here, half, so x to the negative half power over 2, that would be, 1 over the square root of x over 2, or, essentially, one sec. That would essentially be half over, the square root of x. So, cosine square root of x times half over square root of x.
Right, or you could see cosine square root of x over 2 square root of x.
Okay,
Yeah, great. All right.
thank you.
And let's see, 4. Anybody has any questions? Okay, Ree wants to show 4. Go ahead. Let me make you a presenter.
All right, I'll upload the work.
Okay. Ree and is there a negative? No, there's no negative, right? Sine, derivative of sine is cosine. Derivative of square root of x is 1 over 2 square root of x. No negative sign.
Okay.
Yeah,
So
okay.
for number 4, y equals sine cotangent x. So first the outer layer is sine x. The inner layer is cotangent x. So first derivative of sine x. So which is cosine and cotangent x, and also times derivative of cotangent x, which is negative cosecant square x. And then so like if we, I rewrite it, so it's gonna be negative cotangent x, cosecant square x times cosine and cotangent x.
Perfect. Perfect. Thank you very much.
All right, thank you.
Okay, so who's the first one to wanted to show?
It was me, Malika.
Oh, Malika. Yeah, go ahead.
Yeah. So let me just share it.
You know, you see the work like a wreath is perfect. All right. Gradually, I hope everybody can do that.
Okay, can you guys see this?
Yeah.
Okay, so what I did was, since there's like two functions, so f of x and g of x, I put f of x is equal to x over to the power of 4, and then I found the derivative of f prime x, which will be 4x to the power of 3, and then I found g of x, which is 2x to the power of 3 plus 5, and then g prime of x will be 6x to the power of 2. So y prime would be equal to f prime g of x times g prime x, and then you just substitute everything in, and you would get y prime equals to 20 times 2x to the power of 3 plus 5 to the power all that to the power of 3. So,
Perfect. Great.
okay.
Thank you. All right,
You're welcome.
anybody has any question? We essentially find f of x, g of x, f prime of g of x. All right. So Amir, if the function can be written as f of g of x, right? Then h prime of x, that's a chain rule, equals to f prime takes g of x as input, then multiply by g prime of x. Okay, any other questions? So that's by chain rule. Okay, if we can see a function as a composition of two functions, well, we just take a derivative of the outside layer, but the outside layer takes the inside layer as the input, then multiply by the derivative of the inner layer. Okay, any other questions? Okay, if not, I see you on Thursday, all right?
Professor,
Yes.
can I see the questions that we have to do for the homework?
Oh, you see in the chat? Amir wrote in the chat. Pages one, let me show applications. It's 8 to 14, 8, 10, 12, 14, even numbers. 22, 24, 26, 28.
Okay, thank you.
You're welcome. Any other questions? Okay, if not, I see you on Thursday, all right? Okay, presentation, basically everybody have to show it, okay, have to do it. Okay, anyway, so see you